Hi, I'm Luke from BagMe and welcome to episode 4 of Making Materials. In this episode, we're going to be taking an in-depth look in how the 3D spacer mesh for your shoes and backpacks is being made. And it's all happening underneath this awesome 1000 kilowatt solar power system. Before we show you inside the factory, we're going to go into the meeting room, cool down a little bit, and I'm going to introduce you to Honggu. He's one of the main sales managers here, and he's going to give us a little bit of a rundown of the history of Ducksan mesh. Honggu, thanks a lot for having us here at Ducksan.
Yeah.
Really appreciate it.
I'm really happy to have you guys here.
Great. I think we've got some really good drone shots on the roof too, so I'm really looking forward to seeing that.
Yeah.
So,
must be scorching hot there.
yeah, it's super hot, especially for a ginger like me. So before we go any further, I'd really like you to introduce yourself to the audience, and then we'll have a bit of a chat about Ducksan before we get out in the factory and see how things are done.
Yeah, my name is Honggu, born and raised in Busan. I have worked at Ducksan for about 11 years, and then 9 years in Busan as a shoe business sales representative. And then I moved to Vietnam about 2.5 years ago, and then now here we are.
Okay, great. And so Ducksan started in Korea, in Busan, back in 1988, right?
Mr. Yu, our CEO, started a textile business in 1988 near Seoul first.
Near Seoul. Okay.
Near Seoul. And then we started a business with a PVC mono first. And then we developed the material for backpacks first. Then in the 80s and 90s, shoe business was so big. So shoes in Busan, that's why we wanted to open our sales office in Busan. And then we still developing materials both in Seoul and Busan, both for backpack and shoe.
Okay, great. But both locations do both backpack and shoe mesh, right?
Yeah.
And this location here, Vietnam, when did that open?
We opened our factory 2017.
2017.
Yeah. We need to innovate materials again and again so that we can be more competitive, and then we can supply innovative materials for all the brands.
Okay, and this is why like the biggest players in the shoe industry and in the backpack industry is actually working with you on materials rather than just purchasing straight out of catalogs, right?
Backpack brands and shoe brands are looking for different materials. Yeah. Backpack brands wants to find looks simple, but they really care hand feel, the color migration, something like that. Yeah. But shoe brands wants to make a much sophisticated and durable material. We started a textile business with a PVC monomesh. We supplied knits and then other stuff, but we put a lot of effort about 15 years ago to develop jacket woven materials.
Making the whole uppers of shoes and things like that, right? Yeah. As far as the backpack industry goes, the way we see Ducksan, and I think I'm speaking for a lot of people in the industry, is when we're looking for something special, it's really the Ducksan catalogs we look at first. You know, when we're looking at what's new, it's always you guys we sort of look at first.
That's flattering us.
No, cool. So how about I think people are waiting for us to see what's going on out in the factory. Can we go out and have a look?
No problem.
Alrighty, let's get started. So the yarn for most mesh materials are going to be delivered in rolls like these. Now, the yarn cannot be delivered into the knitting machines you're about to see directly from these rolls because the yarn has been spun onto these rolls unevenly. And the knitting machines require literally thousands of rows of yarn all lined up in a row, fed directly straight into the machine and under high tension. So all of these strands of yarn need to be transferred from these rolls onto what's called warp beams, like these ones. And that all takes place using this rack system here, where literally hundreds of rolls of yarn have been placed onto this rack, and each individual piece of yarn is being pulled through this system and all the way to the end where it's rolled onto the beam. The setup of the knitting machine begins with installing 6 warp beams onto these huge shafts. Then, one by one, up to 7 of these shafts are carried through the factory by a huge crane system and placed into position over the knitting machine. The setup you're watching today is to make 3D spacer mesh for shoes and only requires 4 shafts. It takes about 40 minutes to install these shafts, with each shaft weighing almost 2 tons. After the beam shafts are installed, the yarn is left hanging from the beams, ready for the team to pull it all down and start threading it through the machine. Each beam, it's like the roll, has 460 yarn rolled around the machine. And we have 6 on each shaft. So that's nearly 2,800 pieces of yarn that are going to get pulled through this machine. Now, that's times 4, because there's 4 shafts full of all of this yarn getting fed into this machine at once. Now, this is a job that really requires patience, and it's something that I'm never going to be able to do. She's got some tape, and she's taping every piece of yarn to make sure that it's all sorted out in a nice long row. So as they drop it down through the machine, the next person can catch it and everything's all in order. Now, to make sure that all of these yarns stay in order, there's like a fine comb here that goes all the way along the machine, and the yarn has to be all individually sorted into its own piece of the comb. The comb is actually shaped like this, and then this little steel rod will get pushed through to make sure everything stays in place. No, okay. Okay. She's telling me that all of these have to be straight and tight, and that the yarn on the outside can't be rubbing on the edge of the beam. So it really needs to be lined up perfectly. Precision is key here. Each strand of yarn is guided through a series of combs aligning every thread evenly. Setting this up precisely is crucial to ensure the mesh is knitted smoothly and consistently without any imperfections in the material. Now, it's been a couple of hours now, and as you've seen so far, it's really detailed work and something that my eyes wouldn't be capable of taking care of, that's for sure. Now, after that side of the machine is set up, they have to come over to this side, because the material that's knitted in this machine is a double layer. There's a front and a back. They're going to take all this old material out and pull all of the yarn through from these shafts, and they're going to guide all of that through this side of the machine the same way as they're doing on the other side. It's a lot of work. So it's now 6 hours since this machine was empty, and now I literally have thousands of pieces of yarn coming over my head and going into the machine here. And now Lynn has come in, and her job is to get the machine running step by step and to make sure that every piece of yarn is in the right place in the machine. So Lynn just had the machine running for about 30 seconds, and then on this side she's just found this loose thread in the machine here. And now she's going to re-thread it into the right position, strand by strand. Hopefully it's not too long now until we're going to see this machine running at full speed. Alrighty, it looks like this machine's running full speed now. Everybody's disappeared, and so I'm guessing everything's fine. The last thing I saw was the boss come in here, checking everything himself, and he put a few cut marks. And I think that was to mark the line between the test material and the perfect material that's now rolling out of the machine. So here we are, we're now producing mesh. That's really an amazing setup. Ducksan make a wide range of high quality and innovative mesh materials, commonly used in products like backpacks and in the tops of shoes. This 3D spacer mesh has a front and back layer. These layers are linked together by thousands of strands of yarn, giving the material a structure feeling similar to a foam, with a bit of bounce in the material for added comfort. Let's take a closer look at how this is done. This mechanism at the top here is moving back and forth, carrying the yarn with it. First knitting a line at the front of the material, then knitting a line at the back of the material, while in between linking the yarn from the front and back layers, forming the 3D structure. If you look closely here, as the mechanism moves to the front, a row of hooks comes up from the bottom, and then another group of yarn is moved to the side, wrapping yarn around the hooks. The hooks then retract downwards to form a row of knitted loops. The mechanism then moves to the back, again carrying the yarn with it. Another set of hooks comes up from that other side. A group of yarn is moved to the side, wrapping around the hooks then retract, and the process is repeated. At full speed, these machines can run up to 800 cycles a minute, row by row, creating high quality 3D spacer mesh with all sorts of intricate patterns and designs.
And that's how 3D spacer mesh is knitted. Now, this undyed material, also called greige, obviously needs to have some color put in it. Ducksan have their own in-house dyeing facility over in the other factory over here. We're going to take you over there, but on the way, we're going to show you a few more things that are going on here at Ducksan. So over here we have what's called circular knitting machines. And as the name suggests, the knitting process is happening around in a circle, around this cylinder here. And the result is that the fabric is being knitted in a tube. It's very similar to a sock machine if you've ever seen one. So in this machine, the yarn is coming off the cones here. These little devices create tension, and the yarn is going down in and fed to where the needles are here. This one here is a monofilament knitted material, which is mostly used in shoes. We don't really use these in backpacks. But for backpacks, we can use polyester knit, which has a mechanical stretch, and we can use that underneath shoulder straps and for certain other parts of the backpack inside, for lining and pockets and things like that. Now we're going to head over to another part of the factory where they're doing standard weaving and jacquard weaving. The machines you're looking at here are actually what we call standard weaving looms. Unlike the machines we just watched being set up in the other part of the factory, which actually knit the fabric, these machines actually weave material into a more standard fabric, very similar to what we use in backpacks. However, what's being weaved here is specifically made for shoes. These machines have an average of about 9,500 strands of yarn that are threaded through these shafts here. The machines are running at about 400 cycles per minute, and you can see here the fabric is being created with very standard weave material. So here at Ducksan, these jacquard machines are mostly used to create the tops of shoes. Now, the pattern for the top of the shoes can be created in many pieces along the fabric here, and then they're cut out to be formed over the last to create really lightweight shoes. We made an entire video about how these machines work. It's in our episode 3 of Making Materials, and I'll leave the link below so you can check it out. So let's head over to the dyeing facility now. We have got Ludger Sommer from Thies waiting for us. And Thies is a huge German company who make the dyeing machines that probably dye the materials for your clothes. So let's go meet him. Hey, Ludger.
Good to see you here.
I really appreciate you being here with us today. So, tell us what we're looking at here.
You're looking at a modern integrated dye house with machinery that is mainly focused on energy and water saving and quality production of fabrics for your bags.
Okay, and my shoes.
And shoes, exactly.
One of the things I notice when I come into this space is that I don't have that strong smell of chemicals that I've experienced in other dye houses. Why is that?
Because here there is no chemical handling, manual chemical handling. It's all automatically dispensed from a central point.
Okay, and that's actually fed through all of this piping that we see up here, right? Into
Exactly.
the machines individually.
Exactly. Individually, the machines call for their chemicals, and nobody's actually handling these chemicals.
Okay, you're going to show us how all of this works, right?
Yes,
Okay.
we do.
So how about we start with the dyeing machines? Can you run us through how all of this works?
Yeah, we can, but I would say we take it over to the other side, to the soft TRD machines. These are our soft TRD S3 Series 3 Thies rapid dyeing machine, the latest version, with our latest controller systems, which here in this factory, it's a operator interface. The actual controls we will see later in the central control rooms.
Okay. And what's the difference between this machine and that one?
This machine is for very sensitive fabrics and fabrics that are not heat set prior to the processing. Here, this machine treats the fabric very gently, prevents distortion, because when we look at the side of the machine, the fabric itself is rotating in this direction, and in the main chamber, the fabric is actually supported and floating on water, so that it's really treated very softly, and we have very short distances for any lifting and very soft treatments in these pipes and in these transports.
So this machine here is used for polyester and nylon.
Polyester
correct?
and nylon.
And is more for delicate materials.
Yes, exactly.
Okay, so let's run through the process. How many steps are there in this process?
Between 4 to 6 steps, depending again on the color and depending on the after treatment.
Okay, so step 1.
Step 1 is basically a washing of the fabric. Get rid of all the residue from the pre-production, from the knitting or anything.
Okay. First, I saw the guys feeding fabric into here, right?
Exactly.
Okay.
Fabric is fed over the rollers into this main part, the nozzle. Then it's transferred through this pipe to the back of the machine, and then the fabric is stored in the chamber on water, going over this winch that is driven by this motor, and then is continuously rotating in a continuous loop. There is a detergent and washing agent added through the dosing tank into the machine,
Okay.
washing the fabric, and then dumping that washing water, that rinsing water, and then we already come to step 2.
Okay, so water gets drained out
Yes,
between every step?
yes.
Okay, so step 2.
Step 2 is the actual dyeing process. Water is filled up again. Chemicals and dye stuff are automatically prepared in the dosing tank over there. The dosing and the addition of the chemicals and dye stuff takes place automatically. And then once that is finished, the actual dyeing starts by increasing the temperature and controlling the circulation.
Okay, and increasing the temperature, this is for polyester, right?
For polyester, mainly,
Okay.
yes.
So dyeing polyester is about increasing the temperature to open up the
fiber and increase the temperature under very controlled circumstances. Really with a very, very controlled speed, a gradient up to the maximum temperature to evenly open the fibers to be able to...
so the dye stuff can get in.
Exactly.
And just briefly, how is nylon different than that?
Nylon has different dyeing processes, reactive, acid, metal complex. It's not so much temperature dependent, it's more chemical dependent.
Okay, and it uses more water, right?
A little, depending on the color, can use more water. Again, due to the after treatment and
More
process
steps.
and washing, yes.
Okay. Where exactly does the dyeing take place?
Actually, the dyeing and the liquor exchange takes place here in the nozzle.
The liquor is...
The water, not that liquor, it's mistaken a few times, but we call it dye
that's
liquor,
dyeing
this
solution.
mix of chemicals and dye stuff. It's basically penetrating the fabric in the nozzle and then transporting with this water and with the dye liquor, transporting the fabric in the loop continuously.
Okay.
But the actual dyeing process takes place mainly here.
Okay, and during that step 2 process, like how long does it take for the whole, roll the fabric to roll through this machine?
It should be not more than 2 minutes. The fabric needs to be kept in rotation, simply because on higher temperatures the fabric is a little bit unstable, and if it's stationary, is
So it just needs to keep moving so it doesn't settle and create inconsistencies.
and create creases.
So dyeing takes place here.
Yes,
Fabric's coming through the machine, driven by this, and
the liquor is
getting injected into the fabric basically
exactly.
at this point here. And then
through the transport pipe, and then through the back you can see the water and the fabric coming out very relaxed at the end if you look into this. There you can see basically the exit of the transport pipe where the fabric is openly coming out with the water and slowly floating down into the chamber for
it's not slowly actually, it's quite quick.
150 meters per minute. The important part in dyeing in polyester is really the temperature control. To really have a controlled temperature increase to slowly open the fibers to be receptive to the dye stuff. The temperature is reduced down to 60 degrees, 65 degrees. The water is drained.
And then we go on to step 3.
Then we go on to step 3. That's the neutralization and first washing, where polyester dyeing is done at a low pH, which is then neutralized in the step 3, and the first washing of any residues on the fiber and on the fabric is flushed out. It's a very short process of 10 minutes, and then again the water is flushed out.
Okay, so between every cycle that water is flushed out.
Exactly.
Now just briefly, when that water is flushed out, I believe that hot water is used.
This water goes to a collection tank in the back.
Yeah.
And then we have supplied a heat recovery system to get that heat energy, the steam energy, out of this effluent to heat up their normal operational water here to a higher level.
So the heat from the water being flushed out is used to preheat the water coming into the
Exactly.
system. Okay, so that obviously saves a lot of energy.
Exactly.
And we'll have a look at that also soon, I believe.
Exactly.
Okay, so now we're on to step 4.
Step 4 is in terms of polyester, when we have dark colors and very, very bright colors, we have to do a reduction cleaning. Reduction cleaning is basically to make sure that all the residue molecules that are not completely encased in the fiber, that all these surface molecules are washed off.
And that's also going to help with color fastness?
Exactly. The color and washing fastness, because all these open molecules that are still visible on the surface would otherwise, with water, with heat, with sweat, start bleeding.
So step 5 is not for every material?
Not for every material, but step 5 is then again a residual and final wash after this reduction cleaning, to get rid of all the residue of this clearing process and make sure that the fabric is clean, but also for handling for the operator that it's cold.
Oh, okay.
Right? Otherwise the fabric, the polyester dyeing is always a high temperature process.
So this is a cooling down process as well. So when they're unloading the machine,
exactly,
they're not dealing with super hot material.
It's warm enough as it is.
Yeah, certainly is. And the jet dyeing machines, do they work in a similar way?
I think we have a look at the machines directly and go over there and...
Okay, they can go over there. Yeah. So these here are jet dyeing machines, right?
Yes.
And how are they different?
The general concept of dyeing and the process on the chemistry is the same. Just the handling and the path of the fabric inside the machine and the storage of the fabric is different. These machines work on a much lower liquor ratio, material to liquor ratio, than the long flow machines.
So they're more efficient?
They are more efficient, but they have a certain limitation with very sensitive fabrics. That's why we have a mix and match with those.
And what about water usage for these machines?
The water usage here, we talk about roughly 25% lower than the soft flow machines, the TRD.
Okay, and that's why with the soft flow machines, we just handle more delicate materials.
Exactly.
But in effect, we could dye the other materials in there if we needed to. But this is more efficient.
Exactly.
So I see this is one of the smaller of the jet dyeing machines. How much material can this dye?
This has a nominal capacity of 100 kilos. And we have them from 100 kilos all the way to 2,000. But here we have 100 up to 500 kilos.
So here you can see them loading the mesh into this dyeing vat here. And if you look carefully up in there, you can see that it's actually being wound through the machine, coming down into the bottom here. So Ludger, we just filmed this guy loading this machine, and now he's sewing each end together. What's going on here?
He's sewing them both together to create like a continuous loop for the process and the circulation.
When he finishes loading it, connect both ends together so the material can loop around the machine.
Exactly. I would say we go to the dye kitchen and preparation for the chemistry and the dye stuff. which then delivers everything according to the recipe through these pipelines directly to the machines.
And so what are these containers up here?
This is the chemical storage for all the chemicals for the dyeing process.
Okay, so they're like printer cartridges somehow. Like
Exactly.
Dye stuff is in the room behind,
The
right?
dye stuff is in the room behind.
Okay.
Now we come to the second part of the dye kitchen, the dye stuff preparation.
So this system here is not a Thies system, right?
That is correct. This is a semi-automatic weighing system with a storage, automated storage for all the dye stuffs, where the weighing is done very accurate on 2 different scales. This is up to 3 kilo for the accuracy on small amounts. This is to 30 kilo for the accuracy on bigger amounts.
So the information about the color is sent from the central management system
Yes.
out here that we'll go and have a look at next. And then a computer tells the machine to pick up the color tub,
Yes.
bring it down to here.
From there, the ready weighed dye stuff is then taken into this room next door, where we have that's again a Thies system, our dissolving systems, to make sure that all the dye stuff they weigh here is dissolved properly with the right amount of water.
We can have a look in there, right?
Yes.
Okay, like a soup kitchen.
So exactly, all the prepared dye stuff you see in these vats, and once the machine requires the dye stuff, it will call directly. The operator gets a signal, adds the dye stuff in here, and then it's dissolved with the right amount of water and the right temperature, and directly sent all the way to the machine from this pipeline.
Okay, and dye stuff's being delivered right now.
At the moment, both the systems are cleaning, because after every transfer, to prevent any cross-contamination, we're cleaning the whole system to make sure it's spotless for the next.
You would have to clean all the way to the machine.
Yes, we also clean all the way to the machine, but that is already during this transfer. The mix of air and water, we create turbulence to really clean the tank. And here, on these systems, we always use hot water,
Okay.
which has a better cleaning effect on the.
And so this
pipeline.
process of weighing the dyeing powder and bringing it here is basically the only manual.
That is the only manual step in between.
So
Control center.
that's next, right? Here is the control center,
Exactly.
which controls everything.
This controls everything. On the right side, we see the plan board for the production, each and every machine with the current operation and with future processes that are already planned. Also the dosing systems for chemicals and dye stuff, they are all timed and controlled from here.
And what have we got in the middle here? I see a
In the middle, that's actually what we see here now. That is inspection graph, where we can see the whole process and the temperature time curve. As I said earlier on the machine, temperature is vital for polyester dyeing. So in here we can see the actual and the set temperatures, and if the machine is following these actual lines and actual program steps to make sure that the process itself is efficient, but also that the process is completely controlled. He can have a customized report on water usage, chemical usage, energy usage, everything.
Okay, so a brand who's very interested in understanding how much carbon or energy is used to produce their products, they could actually get a report.
Customized for them, just with their data. And if they have comparable systems in other suppliers' factories, they can all give them the same data and the same comparable history of each and every dye.
Okay, great. And if there's an issue with the dyeing, for example, the temperature goes wrong with the polyester, changes the color somehow, you could
You
probably
can
see it.
pinpoint it here. You can pinpoint each and every minute of the machine's operation here.
It's like the matrix of the dyeing industry, right?
Yeah.
So I guess the next part of the process is going to be the water treatment area. Are you familiar with that? Can you show us that?
I can show you the energy and heat recovery system,
Okay.
and I will leave you with that. The water treatment itself is not my strong point.
Okay. All right, I can go on with that after this. So we head over
Correct.
there. Yeah.
Okay,
Good.
let's go.
Okay.
Here we have the effluent heat recovery system. We talked about the draining of the machine, and here we collect all this effluent from all the machines at this high temperature. We use this effluent with this heat recovery system to heat up the cold water that we use in the dye house. So we basically recover the heat and the energy that we already put into it.
Okay. There's obviously a lot of heat and steam coming out of there, and that energy is being used instead of wasted to heat the fresh cold water that's being delivered to the dyeing machines.
Exactly.
And the second purpose is cooling that water down before it goes into the treatment plant, because there's some kind of bioprocess that it ruins if it's over a certain temperature.
Exactly.
Ah, okay.
That is where our part of this big project, Ducksan Wiener, ends.
Okay.
And I hope it was interesting for you to see these points.
Oh, really? Having you here has been fantastic. Yeah, I really appreciate your time here. And when I'm ready to buy my own dyeing system, I know who to see.
I'll take you up on that one.
Cool. Ludger, thank you very much.
Thank you very much.
I really appreciate it.
I'll be around. I have
Okay.
some other. Thank you very
Thanks
much.
a lot. Appreciate it. Okay. Cool. Okay, let's go and have a look at this water treatment system. I know what you see behind me here is not pretty, but it's the harsh reality of the aftermath of dyeing materials. And this wastewater, this chocolatey soup full of chemicals, needs to be cleaned, treated, and turned into crystal clear water again. Okay, so rather than take you through the whole facility, what I've done here is I've got the team to take samples of water out of different ponds, and we'll just give a brief explanation of the basic process, all the way from the waste effluent directly out of the dyeing machines here, all the way to almost fully clean water. Waste water directly out of the dyeing machines. It goes through these processes until it's reasonably clean. The final solids are broken up so they're not suspended in the water. And the final process is extracting this sludge from the bottom, compressing and sending off to a waste disposal facility. And the water has to be stored and then tested and meet very strict environmental standards before it can be discharged. So that's the basics of how the water is treated here at Ducksan. Very important part of the process. Now from over there, the material comes over here, and it's going to be sent all the way down through this line through what's called the final finishing machine. Now, step one, the fabric is getting drawn up through here. And the reason why this system here is moving, it's just aligning the fabric as it's entering the machine, entering the system. Depending on the material is going to be sent through different parts of this system here. So right now, this is a woven material, and it's going through this padding machine where it's being rolled under pressure, and it's having water applied just to give it a consistent wetness across the whole material. Now from there, it's being sent up over this machine. This is not being used right now. This is called a wet straightener, which just helps sort of straighten up the wet of the material that's being fed through the system. The material is now coming down here. The fabric's being pulled through this roller. It's being grabbed by the needles, being set onto the needles here, and now it's making its way into these heat chambers. Now it's on its way through the machine here, and it's going to go through a series of about 8 different heat chambers. Starting here, it's slowly rising in temperature from about 140 degrees, depending on the fabric, all the way up to 180 or 190. And then as it comes through the system, it's going to be cooled down again. Now, the idea is that the fabric is going to set into its final form, its final width, and its final density, where it comes out here at the end. And now here you see the final fabric, very consistent, and it's set into its final form, how we would receive it at the factory before cutting and manufacturing bags. And then from here, the fabric is rolled, packed, and sent out. So let's go and have a look at that final process. So the material is moved to here, it's fed through this machine. The ladies and gents working along this line are going to be checking the fabric as it's rolling through, creating rolls of material, cutting off any faulty parts of the material, and then finally sending the rolls down the conveyor. And that's how it's done. So Ducksan can do a lot more than what we've been able to show you here today. And If you're in the industry and you want to contact Ducksan and possibly do some business, I'll leave the link to their website in the description below, and you can send Honggu a message and see what you can organize. So if you like this content, like and subscribe, because we've got a lot more videos coming your way, and I'll see you in the next one.